Welcome, everyone. Thank you for being here today. I'm excited to kick off this presentation with the theme bricks. On this first slide, we're setting the stage for what's to come. Over the next few minutes, we'll explore the significance of bricks, their history, and their impact on construction and design. So let's get started and dive into the fascinating world of bricks. Bricks are actually one of the oldest types of building blocks used by humans. They've stood the test of time because they are relatively inexpensive to produce, making them an accessible building material for many civilizations. Plus, they're incredibly durable and require very little maintenance over the years, which is part of why they've remained so popular. A brick is essentially a block made from ceramic material, and it's primarily used in masonry construction. Usually, bricks are laid together using mortar, which helps hold everything in place and provides stability. Interestingly, the oldest bricks we've found date back around 10,000 years, discovered in the Middle East. This shows how long humans have been using bricks to build their homes and structures. Ancient civilizations like the Egyptians and the Indus Valley people relied heavily on mud bricks. In fact, in sites like Buhan, Mohenjo-daro, and Harappa, the use of mud bricks is very evident, and in some cases, they used them exclusively for construction. The earliest sun-dried bricks were made in Mesopotamia, in what is now Iraq, around 4000 BC, specifically in the ancient city of Ur. This innovation marked an important milestone in building technology that has influenced construction methods ever since. So, as we see, the history of bricks is really a story of human ingenuity and adaptation, connecting the past to modern building practices. This slide doesn't contain enough information. That's why we're moving to the next slide. This slide doesn't contain enough information. That's why we're moving to the next slide. Bricks offer a range of durable advantages that make them an excellent choice for building. For starters, brick will not burn, buckle, or melt, which means it provides excellent fire resistance and safety. Unlike other materials, brick won't rot or allow termites to invade, helping to maintain the integrity of your structure over time. Additionally, brick won't rust or corrode, so it's highly resistant to the elements. You don't have to worry about dents or damage from impacts. Plus, brick won't fade when exposed to the sun's UV rays, so your building will look good for years without color fading. Bricks are also tough against high winds, rain, or hail, making them ideal for various weather conditions. They require minimal maintenance, which saves you time and money in the long run. Unlike some materials, brick won't devalue over time, maintaining its worth. And perhaps most importantly, brick doesn't limit your personal expression or design options. You have the flexibility to customize your project without sacrificing durability. Overall, these advantages make brick a smart, long-lasting choice that supports both safety and creativity in your building projects. Let's take a closer look at the general characteristics of bricks. A brick is primarily made from clay, which is dried and then fired to create a durable ceramic product. There are three main methods for shaping and sizing bricks: extruded, molded, and dry-pressed. Most bricks are actually produced using the extrusion method, which involves forcing the clay through a die to form the brick shape. When it comes to color, bricks get their hue from the minerals present in the fired clay or from coatings applied either before or after firing. This coloring process results in a durable color that won't fade or diminish over time, which is a key advantage. Now, during manufacturing, bricks undergo vitrification, which causes them to shrink. Because of this process, bricks can vary slightly in size, but don't worry. These variations are actually managed and controlled through ASTM standards. Understanding these characteristics helps us appreciate the durability, color, and manufacturing considerations of bricks, which are all crucial in their application in construction. The method used to form a brick really has a major impact on its texture. For example, when we talk about molded bricks, they often have a sand-finished surface, giving them a distinctive look and feel. On the other hand, extruded bricks can achieve a variety of textures, offering more design flexibility. Now, moving beyond just the appearance, brick manufacturers are also focused on sustainability. They often locate their facilities close to clay sources to cut down on transportation emissions. Recycling process waste is another key strategy, helping reduce waste and conserve resources. Additionally, some companies reclaim land after mining, restoring the environment, and they take measures to reduce emissions from their plants. Most bricks are used within about 500 miles of the manufacturing facility, which further helps minimize the environmental impact. All these points highlight that the way bricks are made not only affects their look and feel, but also ties into broader efforts to make production more sustainable, aligning with our overall theme of responsible building practices. Clay is one of the most abundant natural mineral materials on Earth, which makes it a vital resource for various construction processes. When it comes to manufacturing bricks, however, not all clays will do. They need to have specific properties to be suitable for this purpose. One of the most important qualities is plasticity. This means the clay must be moldable when mixed with water, allowing us to shape it into the desired forms easily. In addition, the clay needs to have enough wet and air-dried strength to hold its shape after it's formed. If it's too weak, the shape could collapse or deform during handling or drying. Another key point is that, once the clay is fired at the right temperature, the particles should fuse together. This fusion creates a solid, durable brick that can withstand environmental conditions. All these properties, plasticity, strength, and the ability to fuse, are essential to producing quality bricks and are fundamental to understanding the raw materials involved in clay-based construction. Let's take a closer look at the different types of clay. Clays generally occur in three main forms, and while they all share similar chemical compositions, their physical characteristics can vary quite a bit. First, we have surface clays. These are typically found near the surface of the earth, often as the upthrusts of older deposits or more recent sedimentary layers. They are relatively accessible and play a significant role in many applications. Next, there are shales. These are quite interesting because they have been subjected to high pressures over time, which causes them to harden and transform into a rock that closely resembles slate. Their durability and structure make them distinct from other clay types. Finally, we have fire clays. These are mined at deeper levels compared to the other types of clay and are known for their refractory qualities, meaning they can withstand high temperatures without breaking down. It's important to note that while surface and fire clays differ physically from shales, they share a similar chemical makeup. Understanding these differences is crucial, especially as we consider their specific applications and how their physical properties influence their behavior and usefulness in various industries. All three types of clay, whether they are earthenware, stoneware, or porcelain, are primarily made up of silica and alumina, but what really sets them apart are the varying amounts of metallic oxides present. These metallic oxides, especially those of iron, magnesium, and calcium, serve as fluxes. That means they help promote the fusion of the particles at lower temperatures, which is crucial during firing. Another interesting point is how these oxides influence the final appearance of the brick. For example, iron oxides can give a reddish hue, while calcium can affect the color in different ways. So, the metallic oxides don't just impact the firing process, they also play a big role in the brick's aesthetic. Manufacturers take steps to minimize variations in both the chemical makeup and physical properties of their bricks. They do this by mixing clay from different sources and different locations within a single pit. This blending helps create a more consistent product overall. However, because chemical composition can vary even within a single pit, manufacturers have to adapt their processes to these differences. They adjust their manufacturing techniques accordingly, which means that bricks from the same manufacturer might have slightly different properties in different production runs. And even bricks from different manufacturers that look quite similar might not be identical in other aspects. So, it's important to remember that appearance alone isn't always a guarantee of identical performance or composition. This all ties back to the overall theme, that understanding the composition and manufacturing process of bricks helps us better appreciate their properties and how they perform in real-world applications. This slide doesn't contain enough information. That's why we're moving to the next slide. This slide doesn't contain enough information. That's why we're moving to the next slide. Let's take a closer look at how bricks are manufactured, which involves 4 key stages. First, there's material preparation. This step is crucial because the quality of the raw material, usually clay, directly impacts the final product. The clay must be thoroughly washed and ground to achieve the right fineness, ensuring a consistent texture for shaping and firing. Next is the manufacturing stage itself, where the prepared clay is shaped into bricks. This can be done through various methods like molding or extrusion, depending on the production setup. After shaping, the bricks need to be dried. Proper drying is essential to remove moisture, which helps prevent cracks or explosions during firing. Finally, we have the firing process, where bricks are heated at high temperatures in a kiln. This step gives bricks their strength, durability, and characteristic color. In the preparation phase, you'll notice the importance of washing and grinding. These are fundamental to ensuring the clay is just right for the subsequent stages. Here, I've included images of a grinding machine and a crushing machine to give you a visual idea of what these tools look like and how they contribute to preparing the material. Overall, understanding these stages helps us appreciate the complexity behind something as simple as a brick, and how each step influences the quality of the final product. Now let's take a look at the brick manufacturing process. First, clay is ground with about 15% water to make it workable. Once the clay reaches the right consistency, it's pushed through a mold that shapes it into a brick form. After shaping, the bricks are cut to standard sizes using a wire, ensuring uniformity. In some cases, larger molds are used, and the clay is pressed using a hydraulic machine. When this method is employed, the clay contains around 10% water. Alternatively, bricks can also be made without hydraulic pressing, which involves a higher moisture content of about 30%. These different methods highlight how variations in water content and pressing techniques can influence the manufacturing process and the final product. Overall, understanding these steps helps us appreciate the complexity and precision involved in brick production. After the bricks are formed, the next step involves identification or perforation, which is crucial for various functions such as structural integrity or future processing. Once the bricks are shaped, they go through a drying process. This is important because wet bricks need to be dried in a space or room where the temperature is carefully controlled. Proper drying ensures the bricks are completely dry before they move on to the next stage, preventing any defects or issues during firing. Before the bricks are sent to the kiln, they are compiled or stacked properly. This step is essential to ensure even heating and efficient firing in the kiln. Overall, each of these steps, forming, identification or perforation, drying, and compiling, are interconnected and vital for producing high-quality bricks that meet the desired standards. Firing is a crucial step in the brick-making process. First, dry bricks are placed in a kiln and subjected to a firing process at around 600 degrees Celsius. This initial temperature is important because it helps burn off any remaining carbon and sulfur residues inside the bricks. Once those impurities are gone, we then increase the temperature further, up to about 900 degrees Celsius, to initiate the vitrification process. Vitrification is a key stage because it causes the bricks to become much harder and stronger. Interestingly, this process typically occurs around 800 degrees Celsius, which is considered the optimal temperature for vitrification to happen effectively. Ultimately, this firing process transforms the bricks, making them durable and capable of withstanding various environmental conditions. This step is vital in ensuring the quality and longevity of the final product, aligning with our overall goal of producing high-quality, reliable bricks. Let's take a closer look at the bricks manufacturing process flow. This slide highlights the key steps involved in transforming raw materials into the bricks we see used in construction. First, it all begins with raw material extraction, where clay, shale, or other suitable materials are mined. These materials are then prepared through crushing and mixing to achieve a consistent composition. Once prepared, the mixture is shaped into bricks, either by molding or extrusion. After shaping, the bricks are dried to remove excess moisture, which is a crucial step to prevent cracking during firing. Next comes the firing process, where bricks are heated in a kiln at high temperatures to achieve the desired strength and durability. Finally, the bricks are cooled and undergo quality checks before they are packaged and ready for distribution. Understanding this flow not only helps us appreciate the complexity of brick manufacturing, but also emphasizes the importance of each step in ensuring the quality of the final product, which ties back to our broader theme of sustainable and efficient construction materials. Let's talk about material preparation. This is a crucial step in ensuring the success of our project. First, it involves gathering all the necessary materials ahead of time, so we're not caught off guard later. Proper preparation helps us avoid delays and keeps the workflow smooth. It also means verifying the quality and specifications of each material to make sure they meet our standards. This way, we reduce errors and rework down the line. Connecting this to our overall theme, thorough material prep is all about laying a solid foundation. Without it, everything else becomes much harder. So, investing time and effort here really pays off in the end. Let's now turn our attention to manufacturing, which is a crucial aspect of how products are created and brought to market. Manufacturing involves the process of transforming raw materials into finished goods, and it's at the heart of supply chains across industries. One key point to emphasize is the importance of efficiency and quality in manufacturing. Streamlining production processes not only reduces costs, but also ensures that the final products meet high standards. This directly impacts customer satisfaction and brand reputation. Another vital concept is innovation in manufacturing technology. Advances like automation, robotics, and real-time data analytics are revolutionizing how we produce goods. These innovations help us become more agile, reduce waste, and respond faster to market demands. Connecting this to the overall theme of our presentation, manufacturing is the backbone of economic growth. It's where ideas and designs turn into tangible products that drive consumer markets and create jobs. Understanding the intricacies of manufacturing helps us appreciate the complexity and the importance of continuous improvement in this sector. Let's talk about manufacturing. Manufacturing plays a crucial role in how products are created and brought to market. It involves the entire process of transforming raw materials into finished goods, which is fundamental to supply chains and economic growth. One key point is the importance of efficiency and innovation in manufacturing. As technology advances, we see smarter factories, automation, and more sustainable practices that help reduce costs and environmental impact. These innovations not only improve productivity, but also enable manufacturers to meet changing consumer demands more effectively. Another important aspect is quality control. Ensuring consistent quality is essential because it builds trust with customers and reduces costs associated with defects or recalls. Finally, manufacturing is interconnected with other parts of the business and the economy. It influences employment, regional development, and global trade. When we look at the overall theme of this presentation, manufacturing is a backbone that supports economic resilience and competitiveness in a rapidly changing world. Let's take a moment to talk about setting. When we discuss setting, we're really focusing on the time and place where the story unfolds. It's more than just a background. It shapes the mood, influences characters' actions, and can even drive the plot forward. A well-crafted setting helps the audience feel immersed in the story, making everything more vivid and relatable. Think about how a stormy night might evoke suspense, or a bustling city can create a sense of chaos or excitement. Connecting this to our overall theme, setting isn't just a static element. It's a dynamic tool that writers use to reinforce messages and deepen understanding. So, when analyzing a story, paying attention to setting can reveal a lot about underlying themes and character motivations. Let's talk about the firing process. When we think about firing, we're essentially discussing how a firearm discharges a projectile. The process begins with pulling the trigger, which releases the hammer or striker. This impact ignites the primer, located at the base of the cartridge. The primer then creates a small explosion, which ignites the gunpowder inside the cartridge case. As the gunpowder burns rapidly, it generates high-pressure gases that force the bullet forward through the barrel. The design of the barrel, including rifling, helps stabilize the bullet's trajectory as it exits. This entire sequence happens incredibly quickly, often in just a fraction of a second. Understanding this process is important because it highlights how different components work together to ensure a reliable and accurate shot. It also connects to the overall theme of firearm operation and safety, reminding us of the precision involved in each step. Let's now turn our attention to packaging. Packaging plays a crucial role in how a product is perceived and how effectively it reaches the consumer. It's not just about enclosing the product, it's about protecting it, making it attractive, and communicating the brand's message. Effective packaging can differentiate a product on the shelf and influence purchasing decisions. It's also important to consider sustainability in packaging. Using eco-friendly materials and reducing waste aligns with broader consumer expectations and corporate responsibility. Throughout this presentation, we've emphasized the importance of combining functionality with branding, and packaging is a perfect example of that balance. Ultimately, packaging is a strategic tool that supports the overall marketing and distribution efforts, ensuring the product is appealing, protected, and aligned with the company's values. Let's talk about the properties of bricks, which are crucial to understanding their quality and performance. The most important properties include durability, color, texture, size variation, compressive strength, and absorption. Today, I want to focus on durability. Durability essentially refers to how long a brick can withstand environmental conditions without deteriorating. Achieving durability depends largely on how well the brick is fired. Specifically, during firing, we aim for incipient fusion and partial vitrification. These processes help strengthen the brick and improve its resistance to weathering. Now, because properties like compressive strength and absorption are influenced by firing temperatures, they serve as good indicators or predictors of durability. When testing bricks, we look at these values along with the saturation coefficient to gauge how durable they might be. However, it's important to remember that raw materials and manufacturing methods can vary quite a bit. This means that a single set of values for compressive strength and absorption can't always reliably predict durability across all bricks. Variations in raw materials or firing techniques can lead to differences, so these measurements need to be interpreted carefully within the context of how the brick was made. In summary, understanding these properties and their interrelations helps us select the right bricks for specific applications, ensuring longevity and performance in our construction projects. When we look at the textures of bricks, one common type is the smooth or sand-finished surface, which is often achieved through the use of dyes or molds during the forming process. A key concept here is the smooth texture, sometimes called a die skin. This results from the pressure exerted by the steel die as the clay passes through it during extrusion. Most extruded bricks have this die skin removed afterward, and the surface is then treated to create different textures. This can be done using various devices that cut, scratch, roll, brush, or otherwise roughen the surface as the clay emerges from the die. Additionally, bricks can be tumbled before or after firing to give them an antique or weathered appearance, adding character and visual interest. Understanding these surface treatments and finishes helps us appreciate the variety of textures available and how they contribute to the overall aesthetic and function of brick in design. Let's talk about the color of fired clay. The color actually depends on a few key factors, including its chemical makeup, the temperature at which it's fired, and how that firing process is controlled. One of the most influential oxides in this regard is iron. Now, regardless of the natural color of the clay, if it contains iron, you'll see a characteristic red hue when it's fired in an oxidizing environment. This is due to the formation of ferrous oxide during firing. However, if we fire the same clay in a reducing atmosphere, what we call flashing or reduction firing, it will turn a much darker or even black color. This change in color is all about the atmosphere inside the kiln during firing. Another important point is that darker colors are generally associated with higher firing temperatures. When clay is fired hotter, it tends to have lower absorption values and higher compressive strength. But, and this is key, if you're working with different raw materials, there's no straightforward relationship between color and strength or absorption. So, in essence, color gives us clues, but it's not the whole story when it comes to the properties of fired clay. This all ties back to the overall theme of understanding how firing conditions influence the final product's appearance and qualities. Now let's talk about size variation in bricks. As you might know, clays tend to shrink during both drying and firing processes. So, to make sure we end up with bricks of the right size, manufacturers make allowances during forming. This way, after shrinkage, the finished brick reaches the desired dimensions. It's important to note that both drying shrinkage and firing shrinkage can vary depending on the type of clay used. Typically, drying shrinkage falls between 2 and 4%, while firing shrinkage ranges from about 2.5 to 4%. An interesting point is that firing shrinkage increases as the firing temperature gets higher, which also results in darker shades of bricks. So, if a manufacturer wants a variety of colors, some size variation between dark and light bricks is inevitable. To achieve uniformity, manufacturers carefully control factors like moisture content and firing temperature. However, because raw materials naturally vary and kiln temperatures can fluctuate, achieving perfect uniformity is impossible. That's why brick specifications always include acceptable size variations. In the end, understanding these variations helps us appreciate the complexities involved in producing consistent, high-quality bricks. Let's talk about compressive strength and absorption. Both of these properties are influenced by several factors, including the properties of the clay itself, how the ceramic is made, and the firing process. For example, if you're working with a specific type of clay and a particular manufacturing method, you'll notice that increasing the firing temperature generally results in higher compressive strength. That means the ceramic becomes stronger under pressure. At the same time, higher firing temperatures tend to lower the absorption, making the ceramic less porous and more resistant to water. While manufacturing and firing techniques do allow us to control these properties to some extent, it's important to remember that they are primarily dependent on the raw materials used. Understanding this connection helps us optimize the firing process to achieve the desired strength and durability, which ties back to the overall goal of producing quality ceramics. Let's take a closer look at the tests on bricks, specifically those outlined in ASTM C67, which is the standard for sampling and testing brick and structural clay tile. These test methods are essential because they ensure the quality and durability of the materials we use in construction. They include procedures for sampling bricks and clay tiles properly, so our results are consistent and reliable. The tests cover a wide range of properties, starting with the modulus of rupture, which tells us how much stress the brick can handle before breaking. We also look at compressive strength, which is crucial for understanding how the brick will perform under load. Absorption and saturation coefficient tests are important because they indicate how much water the brick can absorb and how it reacts with moisture over time, key factors in durability. Then there are tests for the effect of freezing and thawing, which simulate real-world environmental conditions and help us assess how well bricks can withstand temperature changes. Efflorescence testing checks for salt deposits that can affect appearance and integrity. Initial rate of absorption and the determination of weight, size, warpage, length change, and void area give us detailed insights into the brick's physical properties and uniformity. All these tests together help us ensure that the bricks meet the necessary standards for strength, durability, and performance in construction projects. Let's take a closer look at brickwork and the role of brick shape within it. The shape of the bricks is quite important because it influences how the bricks are arranged and how they fit together. By varying the shape, we can create different patterns and textures that add visual interest to a wall. This flexibility allows us to produce a wide variety of arrangements, whether for aesthetic purposes or for specific structural needs. For example, certain shapes can help improve bonding or create special effects, making the brickwork both functional and decorative. So, understanding the importance of brick shape helps us achieve the desired style and strength in our construction projects, tying into the overall theme of craftsmanship and design in masonry work. Now, let's take a closer look at brickwork, which is a fundamental aspect of many construction projects. The shape of the bricks plays a crucial role in how they fit together and how strong the overall structure will be. When we talk about brick shapes, we're referring to the different forms and sizes designed to suit various architectural needs. Moving on to the specifics, one common type we see is the angle brick. Angle bricks are particularly useful when we need to create corners or edges that require stability and a clean finish. They help ensure that the transitions between walls or sections are seamless and durable. Remember, selecting the right brick shape, like the angle brick, is essential for both the structural integrity and aesthetic appeal of a building. This focus on brick shapes ties back to our overall theme of understanding the key components that contribute to a solid and attractive construction. Let's take a closer look at brickwork, starting with the shape of the bricks themselves. The shape plays a crucial role in how bricks fit together, providing stability and strength to the structure. When we consider brick shapes, we're talking about more than just the rectangular form. It's about how those shapes influence the pattern and the overall integrity of the wall. The way bricks are designed and arranged affects not only the durability, but also the aesthetic appeal of the construction. So, understanding the shape of bricks in brickwork is fundamental to creating a solid and visually appealing structure. Let's take a closer look at brickwork, which is a fundamental aspect of masonry construction. When we talk about brick arrangement in brickwork, we're referring to the way bricks are laid out to create a strong, durable, and aesthetically pleasing structure. The arrangement or pattern of bricks is crucial because it directly impacts the strength and stability of the wall. There are various patterns used in brickwork, such as running bond, English bond, and Flemish bond, each with its own advantages depending on the application. For example, the running bond, where bricks are laid in a staggered manner, is very common because it provides good strength and is easier to lay. Understanding these arrangements helps us ensure that the structure can withstand loads and environmental factors effectively. As we continue, keep in mind that proper brick-laying techniques are essential for both the integrity and the appearance of the finished work. Now let's take a closer look at brickwork, which is a fundamental aspect of many construction projects. When we talk about brickwork, we're referring to the way bricks are laid and assembled to create walls, structures, and other elements. The arrangement of these bricks is crucial because it affects the strength, durability, and overall appearance of the finished structure. In this slide, you'll notice we mention brick arrangement in brickwork. This is all about how the bricks are positioned relative to each other. Different patterns, such as running bond, Flemish bond, or herringbone, serve different purposes and can influence both the aesthetic appeal and structural integrity. Understanding these arrangements helps us ensure that the construction is not only visually appealing, but also structurally sound and long-lasting. Remember, the key to excellent brickwork lies in the proper placement and consistent technique, which ties back to our overall theme of building quality and reliability in construction. Let's take a closer look at brickwork today. When we talk about brickwork, one of the key aspects is the arrangement of the bricks. The way bricks are laid out can significantly impact the strength, durability, and aesthetic appeal of a structure. Different arrangements serve different purposes, whether it's for load-bearing walls or decorative facades. As we go through this, keep in mind that the pattern and alignment are crucial elements that tie into the overall quality of the construction. So, understanding the basics of brick arrangement helps us ensure our projects are both functional and visually appealing. Let's take a closer look at brickwork. When we talk about brickwork, one of the key aspects is how the bricks are arranged. The arrangement of bricks, or the pattern they form, plays a crucial role in both the strength and the aesthetic appeal of a wall. On this slide, numbered 35, we see various types of brick arrangements that are commonly used in construction. Understanding these patterns helps us choose the right method for different projects, ensuring durability and visual harmony. So, as we go through these arrangements, think about how each pattern might influence the overall integrity and appearance of a structure. This is an essential piece of the bigger picture in building design and construction. Let's talk about brickwork and how bricks are arranged within brickwork. There are several popular arrangements that are commonly used in construction. One of these is the brick edge arrangement, where bricks are placed on their edges to create specific visual effects. Then we have the brick head arrangement, which involves laying bricks on their face, showing the longer side. The American arrangement is quite popular, featuring a running bond pattern that provides strength and a clean look. The English arrangement, on the other hand, is more decorative, often with a header and stretcher pattern that adds visual interest. Flemish arrangement combines both headers and stretchers in a pattern that looks quite intricate and appealing. In this slide, we're focusing on the American arrangement, which is widely used because of its simplicity and durability. It's a pattern that provides a uniform appearance while maintaining structural integrity. Understanding these different arrangements helps us appreciate the craftsmanship involved and how each pattern can influence both the strength and aesthetic of a brick wall. So, as we move forward in this presentation, keep these arrangements in mind. They're fundamental to both the functionality and the visual appeal of brickwork. Now, let's take a closer look at brickwork, which is a fundamental aspect of masonry construction. When we talk about bricklaying, we're referring to the process of arranging bricks in a systematic way to build walls and structures that are both strong and durable. An important material used in this process is mortar. Mortar is essentially a mix, usually of cement or lime combined with sand, or sometimes both. This mixture acts as the binding agent that holds the bricks together securely. The ratio of binder to sand in mortar is typically 1:3. That means 1 part of cement or lime to 3 parts of sand. This proportion helps ensure the mortar has the right strength and workability. Another key point is the thickness of the mortar joints. Normally, these range from about 6.5 millimeters up to 9 millimeters. Maintaining this range is crucial because it affects the overall stability and appearance of the brickwork. These details, material choice, mixing ratio, and joint thickness, are all essential to producing quality brickwork that stands the test of time, aligning with our overall goal of durable and reliable construction. Sekarang kita bahas tentang brickwork, khususnya bagian brick laying finishing. Biasanya, proses ini dilakukan setelah brick laying utama selesai. Tuannya adalah untuk mendapatkan tampilan yang baik dan hasil finishing yang rapi pada sambungan batu bata. Proses ini bisa dilakukan secara perlahan, baik saat pekerjaan belum sepenuhnya selesai maupun setelah semuanya selesai. Yang penting, kita fokus pada hasil akhir yang bersih dan estetis agar struktur terlihat lebih rapi dan profesional. Selanjutnya, kita lihat juga tentang mortar yang dikemaskan. Jika ada mortar lebihan, harus segera dikorek dan dibuang sedalam 15 agar tidak mengganggu tampilan dan kekuatan struktur. Ini semua sangat penting karena finishing yang baik tidak hanya meningkatkan estetika, tetapi juga memastikan kekuatan dan daya tahan bangunan. Jadi, perhatian terhadap detail kecil seperti ini sangat berpengaruh besar terhadap hasil akhir proyek kita. Now let's talk about brickwork and plastering, which are essential finishing steps after laying the bricks. The main goal here is to achieve a smooth surface and a uniform color across the wall. To do this, we first scratch the wall to create a rough surface, which helps the plaster adhere better and makes the plastering process easier. The materials used for plastering typically include lime, Portland cement, and gypsum. When applying plaster, we do it in 2 layers, a base layer and a finishing layer. The base layer, also known as the rough coat, has specific mix ratios. For example, one common mix is cement, lime, and sand in the ratio of 1:2, 8:9, or alternatively, cement and sand in the ratio of 1:3, or gypsum and sand in the ratio of 1:3. There's also a mix involving gypsum, lime, and sand in ratios like 1:3, 7 to 9. After the base layer has been applied and set, we move to the finishing layer. This top coat uses a simpler mix of lime and gypsum, typically in ratios ranging from 1:0.25 to 0.5. The purpose of this finishing layer is to provide a smooth, polished surface ready for painting or other finishes. Remember, the key here is to ensure each layer is properly applied and cured, as this impacts the overall quality and durability of the wall. These steps, although detailed, are crucial in achieving a professional and aesthetic finish that aligns with the overall quality standards of construction. Now let's take a closer look at some of the advantages of using brick in construction. As you can see here, brickwork offers a variety of decorative possibilities that can really enhance the aesthetic appeal of a building. The texture and color options are quite extensive, allowing for a lot of creative expression. One popular application is in walkways, where bricks not only provide a durable surface, but also add visual interest to outdoor spaces. Their timeless look can complement many architectural styles, making them a versatile choice. Overall, the decorative aspect of brickwork is a key advantage because it combines functionality with beauty. When we think about building materials, it's important to consider how they can contribute to both the durability and the visual impact of our projects. Brick does an excellent job of fulfilling both roles. Now, let's take a closer look at some of the key advantages of using brick in construction. First, durability is a major benefit. Bricks are incredibly strong and can withstand the test of time, making them a long-lasting choice for building materials. This durability also means they require less maintenance over the years, which is a significant advantage for property owners. Next, brick structures tend to have excellent thermal mass. This means they can absorb and store heat during the day and release it slowly at night, helping to regulate indoor temperatures naturally. As a result, buildings made with brick can be more energy efficient, leading to lower heating and cooling costs. Another important point is aesthetic appeal. Brick offers a timeless, classic look that can enhance the character and charm of any building. It comes in a variety of colors and textures, allowing for versatile design options that can complement different architectural styles. Lastly, bricks are also environmentally friendly. They are made from natural materials, often locally sourced, and can be recycled or reused, contributing to sustainable building practices. So overall, the advantages of brick, its durability, thermal efficiency, aesthetic appeal, and eco-friendliness, make it a compelling choice for many construction projects, aligning well with our goal of creating lasting, energy-efficient, and visually appealing buildings. And that brings us to the end. Thank you all for your attention and engagement throughout this presentation. I hope the insights shared have been valuable and will serve you well in your future endeavors. Remember, the key takeaways are about understanding the core concepts, applying them thoughtfully, and continuously learning. If you have any questions or want to discuss further, feel free to reach out. Once again, thank you for being here and for your time.